I would like to introduce Luke Sneeringer, who's here to talk to us about Metaclasses.
Hi there. Good morning. It appears I am on and everything is working, which is amazing for the first track of a conference. So I'm going to be talking a little bit about Metaclasses today. But before I do, I'm going to give a quick intro about myself and kind of where we're coming from. I'm a sole developer at a small software startup working out of Austin, Texas. I'm talking about Metaclasses because I've written a lot of them, and because I think that they're a very interesting topic. I think that they're one of the things that makes Python a much more powerful language while still maintaining a lot of the straightforwardness versus, say, some of the prototypal inheritance where you introduce a lot of complexity very quickly. And as I've had to go and as I've had problems where Metaclasses ended up being the right solution, I found that usually when I decided that I needed to use Metaclasses, it was the right call. Usually it's distinctly not always. And so with that being said, I want to give a little bit of an intro. Metaclasses are kind of a big, scary word. We have books. If any of you have ever looked at or purchased Learning Python by Mark Lutz, it's a massive 3,000-page book. I was introducing a friend of mine to Python, and he called it the cinder block, because that's about how much it weighed. He went to the bookstore to look for this book that I told him to get, and he found a normal-sized book, and then like, whoa, this is this massive book. And at the end of this massive book is a chapter on Metaclasses, and of course it begins with this dire warning, because of course Metaclasses scare people. And because they scare people, authors and experienced Python developers tend to tell people that if you are looking at Metaclasses for the first time, you should run bravely away. And I really should have put a picture of brave Sir Robin up at this point, but I didn't think about it until just now. And in fact, one of the sort of the gods of the Python world, Tim Peters, who, if you type import this into your Python console, you'll get the little limerick that is famous, simple is better than complex and the like, actually said, Metaclasses are deeper magic than 99% of users should ever worry about. If you wonder whether you need them, you don't. And the people who actually need them know with certainty that they need them, and they don't need an explanation about why. With all due respect to Tim Peters, I don't think he's completely accurate. I think that there's validity to that warning, and it's not necessarily good for people to be writing things that they don't understand. We're going to get to that in a minute. But that being said, if nobody who ever doesn't know ever actually has the problem that justifies the solution, then nobody can ever learn them either. And so maybe that approach isn't completely right. So this talk is an attempt to teach Metaclasses. It's an attempt to teach Metaclasses accessibly, and it's an attempt to teach it to people who don't understand them yet. My goal is not to be able to take someone who understands the fundamentals of Metaclasses and be able to make them write something really awesome and complex. My goal is to make someone who doesn't understand what a Metaclass is, who just looks at that and thinks that it's deep, scary magic, and hopefully you walk out of here with a notion of the fundamental building blocks that you could get to know when this is the right solution for a problem. It's also an attempt to defy Python orthodoxy. Always very fun to be the rebel. And make Metaclasses an understandable topic for the 99%. I expect to see an Occupy PyCon hashtag sometime soon. And therefore, it's an attempt to turn some Sir Robins. I should not walk in front of that speaker over there. And therefore, it's an attempt to turn some Sir Robins into Sir Lancelots. And so, without further ado, I'm going to attempt to begin the demystification. There, I got in a King Arthur reference. Just not from Monty Python. Before I do that, I do want to talk a little bit about terminology. The most annoying thing is when someone's using a term and it means different things to different people. In particular, it's in terms to classes and objects, or classes and instances. We can use the word object to mean several different things. Generally, we understand what classes are. I think everyone here knows that list is a class, that dict is a class, that int is a class. And you know that this list up here with 0, 1, 2, and 3 is an instance of class list. That's something that probably we all know. During this talk, I'm going to use the word object and instance to mean pretty much the same thing. I'm always going to be talking about an instance of a class. There's one exception to that, and it will be clear. So I want to get that out of the way so that we know that I'm talking about instances and not about class object. One of the things about Python that's awesome is that classes in Python are objects. In the same way that functions are and methods are and any other kind of variable. They are objects too. They're first-class objects. They can be passed around. You can use them in the same way that you can use any other variable. And to demonstrate this point really fast, I'm going to set up a very trivial example, which is this asNumber function. What this number function does, if you send it one argument, is it returns the integer representation of that number, or if it won't work as an int, it will raise type error. There's a second argument I've added here, this class that you can send. I'm sending the int class by default. And it accepts a class as an argument to override that behavior. So using my previous example, if I send string 314 and nothing, it will send back 3. But I can send the float class as the second argument, and it sends back the 3.14 float. As a quick clarification, it will actually take any callable. You could have sent a function in there instead of a class. But that's really not the point I'm trying to make. The point I'm trying to make is that you can pass these callables around at all. In a lot of the languages, you can't. That's just not something that you can do, or you have to do it by some really complex mechanism like passing a string and then calling some class name function that's built in. The ability to pass classes like this is a big reusable code toolbox thing. It's something that makes Python very useful for writing code that other people are going to use. But again, that's not the point I'm trying to talk about. Let's talk about instances real fast. Since classes are objects, I want to go over very quickly, and I'm a little bit behind, so I'm going to talk fast, how objects are made. This is the basis for how classes are made, which we're going to get to. So let's say that we have this class. I'm going to show it very quickly, but it's a class to represent a cat. Cats have a sex, male or female. They hopefully have a name. We know that they're part of the mammal kingdom, and there might be some things that you can do with a cat. If you're an animal shelter, you could adopt the cat out to an owner. So let's say I instantiate a new cat, such as this one, Shadow. By the way, if anybody catches the reference for where all those names came from, bonus points. What actually happens? Well, the first thing that happens is a new object is created, and it's assigned to the shadow variable and given the type of cat. I'm going to talk more about type in a minute. That's a very important word. And if you were to do this code in the Python shell, this is what you would get. Type would come back as cat. These class variables are a reference back to the class. If you alter the kingdom of any cat, it would alter it for all of them. So if you go and assign cat.kingdom to plant, then it will affect shadow.kingdom. I don't know why in the world you would decide that your cat was a plant, but maybe you're strange. Any methods that are assigned to the class are what's called bound to the instance. This is the magic. There's some other talks on this, but this is the magic that makes the self keyword first argument do what it does. So if I were to call cat.adopt and send one thing, it would give me a type error saying that the first argument isn't actually a cat. But if I call shadow.adopt, it works just fine. And then after the instance has been kind of set up, the dunder init method runs. The key point to take away from all this is that the instances are constructed at runtime. The class might be constructed at runtime as well, might be in memory somehow, depending on how your thing is running. But when it comes time to set up the instance, it gets run, and this is the kind of the steps that happen. And the other key point I want to make is we talk about instances of classes as having their class. Shadow is a cat. It's an is a relationship. What we don't necessarily understand, a lot of us, is that classes work the same way. In fact, they are instances. No, really. Classes work the same way. The syntax is a little bit different, but something very, very similar is actually happening. In the same way that objects are instances of their class, so Shadow is an instance of cat, classes are instances of their metaclass. And metaclasses are themselves classes, with the base classes being their instances. Again, I'm going to take a second to talk about terminology, because Metaclasses is a big, scary word. Let's talk real quick about why we use it. Once upon a time, in about 400 BC, there was this guy. You may or may not recognize him, especially since all the drawings I found in the Google images were pretty substantially different, but it's supposed to be Aristotle. Aristotle wrote a lot of stuff. I would like to mention that I was a philosophy major in college. I love to read, and Aristotle puts me to sleep. So if you want to have an intro to philosophy, don't start with Aristotle. Plato is much more fun. That being said, the term meta is actually a Greek prefix. It means after. I also am trained in classical Greek, and Greek has lots of prefixes that you can stick on words. Epi means good, mal means bad, etc. Meta means after. Aristotle, in writing this, divided his work into a bunch of chapters. One of the chapters is the physics. The next chapter is the metaphysics. In fact, the issue here was Aristotle had this big writing on lots of esoteric things, and he had no idea what he wanted to call it. So he just settled on calling it the stuff that comes after the physics. We've evolved the term slightly to mean self-reference. When I say self-reference, probably most people in here have heard the term metadata, the data about the data. Really, anytime you hear meta X, it's just the X about the X. So instead of meaning after, it now kind of means about in a self-referential way. Therefore, metaclasses is just the classes about the classes, or the classes, in this case, that created the classes. That's all that a metaclass is. And again, I keep coming back to this point because I want to make it as clear as possible. And if I say this in 3 different ways, I'm hoping that saying it in different ways will resonate with different people. We all know that classes provide for the creation and, what's the word I have there? Execution of their instances. Classes tell us how instances are to behave, how they're supposed to be constructed, how they're supposed to run, what they have, all that kind of thing. Classes are themselves instances, and metaclasses are their classes. Therefore, metaclasses provide code for the creation and execution of classes. Notice that my first bullet and my third bullet have identical wording with those terms flipped or subbed out. And the last way I'm going to illustrate this is with the analogy section that, at least if you're from the United States, you probably took on the SAT test. You probably saw something like this. Orange is to fruit as celery is to blank. And you would have a multiple choice answer where you would have to state what the appropriate word there was. And of course, in this case, the answer would be vegetable. This is the appropriate analogy to understand classes and metaclasses. Instances are to classes as classes are to their metaclasses. And with that, I'm going to hope that understanding is clear. Actually, I'm not. I have one more example, which is consider a self-enclosed machine that creates t-shirts. The t-shirts are the instances. The machine is the class. The guy who builds the machine that makes those t-shirts could be conceived of as the metaclass in this conception. And with that being said, I'm going to get down to some of the details. Probably most people here have made a normal class. You inherit it from object. This is something that we've all done. If you're using Python 2, you inherit from object explicitly. If you're using Python 3, you inherit from object implicitly because old style classes are gone. Metaclasses inherit from type. Type is another built-in. It's in the chain. You can type in your Python console and you'll get something back. You'll actually get back type. Classes with no explicit metaclass, which is the vast majority of the classes that you'll ever write, are built by the type metaclass. Well, technically this is only true for new style classes, for Python 2 folks, but if you're using old style classes, you're probably doing it wrong. So remember that cat example earlier where we made shadow? But what happens when we're actually processing the class cat? So the Python interpreter, before it created shadow, it went through your declaration of class cat with that code block that I put up earlier. I'll have it up again. The class syntax in Python is a shortcut to class construction the hard way. If anyone remembers in math classes you took in college or in high school where they teach you the really long way to do something and then they teach you the shortcut, like these wonderful calculus shortcuts. I remember those. I don't remember how to do any of them the long way. But I'm sure some of the real engineers in here can tell me. So let's go back to our cat class. Again, this is the shortcut. This is the nice, pretty syntax that we all learn and can remember. This is nice shorthand. It's really not anything more complicated than nice shorthand. It's just that we don't know the details of how to make a class the long and hard way. But when we do that, we'll understand metaclasses a little bit better. So I'm going to go through making this cat class the long, hard, and ugly way. So first we have our functions. These are basically the same functions we looked at earlier, except I added a pass to def adopt. I didn't feel like defining it. But other than that, these should look really familiar. I renamed dunder init and removed the double underscore. But other than that, these are the same. What happens internally is all the attributes that you put on get assigned to a dictionary, or are put in a dictionary. And I'm doing that manually here. So you have dunder init as the key and the init function being passed, the adopt key and the same thing, and then the kingdom and mammal thing that we saw in our cat class earlier. We have to know what the superclasses are. In Python, we have multiple inheritance, so superclasses are a list. In this case, our cat class just inherited from objects, so our superclass is a linked one list with object. And then all it is a call to the type constructor. So I have here the assignment to the variable cat. I'm calling the type constructor. I'm giving it a name, which is, again, cat. And then I'm passing the superclasses and attributes. That's all that's happening. This is just a lot uglier and a lot harder to read. All of this should be familiar Python, except for maybe that call to type at the end. The last thing is the call to the type constructor. It takes 3 positional arguments, the name of the class, a list of superclasses, and the attributes. And that's really all. The only key difference is this is uglier, and we don't ever want to do it. What actually is happening here is that 2 methods are getting called, type.dunderNew and type.dunderInit. These are the things that make the classes in the same way that you would see if you had your dunderInit method in a class that you created. They take the same 3 arguments. They actually each have an additional argument that gets added in the front, a lot like how self works. But I'm not going to go into that. But that chunk of ugliness we just looked at gives you the same thing. The only difference, really at all, is that you're going to have a slightly more cluttered namespace. And you're also probably glad that you're not writing that all the time. In fact, you should throw a party. Basically, the class cat statement is going through that exact process. Metaclasses are for the edge cases, where this pretty shortcut doesn't work. In my derivative and integrals that I posted earlier, there are a couple cases where those equations break down, and you have to do it the long way. That's exactly what metaclasses are. So let's look at the simplest, or let's understand one more thing about type. Remember I said that type is a built-in in Python, and it's the top of the tree. So if I make a spam class that has nothing in it, it just inherits from object, I declare an instance of it, which is s equals spam. If I ask the Python interpreter what the type of s is, it's going to tell me that it's the spam class. What if I ask it what the type of the spam class itself is? Well, then it's going to tell me that it's a type of type, because type is the metaclass for the spam class. Incidentally, the type is actually the true top of the chain. If you run type on object, type will come back. If you run type on type, type will still come back. Type is actually the true top of the class chain in Python. So to create a metaclass, all you have to do is create a class that inherits from type. Whereas a normal class is something that inherits fundamentally from object, a metaclass is something that inherits from type, or obviously one of its subclasses. So that's a metaclass right there. That's all it is. It's just another class. And in fact, it has type as its metaclass. Now, of course, this metaclass does nothing. But that's beside the point. The other thing you have to do is when you're instantiating your concrete classes, you have to declare what metaclass you want to use if you want to use something other than type. The syntax for this is a little bit different depending on what version of Python you're using. If you're using Python 2, then you actually has an attribute, a dunda metaclass attribute that handles the magic of assigning the appropriate metaclass to your final class. If you're using Python 3, it's a little bit better. There's what looks a whole lot like a keyword argument that gets sent at the top of the class declaration. Now we just have to cover how in the world we got our metaclasses to do something. The most straightforward case, and the most common case for a metaclass, is actually overriding that dunder new and dunder init method that I talked about earlier. These are the things that run when a class is created. And if you override them, then you get special behavior. Remember, these run when the class is created, not the instances. So if I were to assign this metaclass to one of my final classes, when the class declaration ran, it would print these statements out to my console or wherever my print statements were going. Or if you're using ModWhiskey, it will throw an error saying that you're not allowed to use print. These are the primary hooks to add and remove things from the metaclasses. This is actually how Django models work. For those of you that have ever used Django, you've almost certainly written the model, anything that subclasses models.model, and you've written things like so-and-so equals models.foreign key, so-and-so equals models.carfield. There's actually a metaclass called model base, and what it does is it airlifts all of those out of your primary attributes into a place called under meta.fields, and then it puts in those same attributes on the instance with the keys set to sensible defaults that can be overridden later by the stuff in your database or the stuff you're providing to your class constructor or whatnot. It also does lots of other things. But that's the model-based metaclass. The last thing I want to cover is when metaclasses are the right option. Metaclasses are the right option. Usually, the most common case for when metaclasses are the right option is if you're writing an API or an interface for future classes and subclasses to be written later. The goal here being that you can write a much simpler class or a much simpler subclass following a defined and simpler API that makes those classes easier to read. And the ease for those classes offsets the complexity in the metaclass. Django models are a great example of this. Can you imagine trying to write or shoehorn the code in that does all of that stuff every single time? It makes the Django API much easier to program against because they're using metaclasses. In short, they're useful for making your concrete classes much more straightforward, less likely to be buggy, that sort of thing. This isn't technically a metaclass, but I feel like it would be an incomplete survey of this topic not to discuss it, which is programmatic class creation. Because classes are first-class objects, because they are these things that you can handle in procedural ways, you have an extra bit of power that you don't have in some other languages. Sometimes metaclasses aren't the right answer, but you still need this concept of not necessarily knowing everything about your class when you're writing your code. This is the case where often metaclasses look very attractive, but sometimes this is an easier mechanism. While not technically a metaclass, note that you can create classes programmatically in a function. We discussed how to do it earlier when I showed the call to the type constructor. Sometimes you want to create a class programmatically. I'm going to call this function a class factory. Remember that cat class? I just said this. Wrap it in a function. If you wrap it in a function, then that class is a new class for that thing is being generated every time a function is called. Now, of course, there are some disadvantages to this. There's reasons not to do it. A class factory function is handled a little bit differently than a class. In particular, a new one is created every time you're calling the function to return it. So you have some expense there. You might have some behavior that doesn't work exactly like you expect. If you created that new cat class and made two different instances, that kingdom mammal thing that you would expect to be related wouldn't be, because they would in fact be two different classes with the same name. But it's often a very useful tool when there's some aspect of class creation that you can't know until execution time. And there are needs for this. And with that, I'm going to go to practicing a little bit of wisdom. I said at the beginning of this talk that discussions of metaclasses often come with dire warnings. Run bravely away, away. There is a little bit of justification for that. I very much poo-pooed that earlier, and I stand by that. But there is some justification for it. It's not to your advantage to go meta if you don't need to. There is complexity added. It can be the right solution. It can make your stuff much simpler. It can also make your stuff much more complicated if you have classes that you don't need. In this room, 2 talks from now, Jack Dietrich is going to be talking about when people write classes when they should write functions. If you attend that talk, multiply that by 10 for if you write a metaclass that you don't need. But at the same time, if you need it and it's the right solution, don't be afraid to go meta, even if you have some questions, even if there's things about writing metaclasses that you don't understand yet. You're not going to leave this talk knowing everything there is to know about metaclasses. That's not the goal. There's no way that could be covered in 25 minutes. But that being said, there's lots of information on this topic. Mark Lutz's discussion in Learning Python is great. You can always tweet me. I am not as much of an authority, but I'll be happy to try to help. And if you do need this, it is something that should be considered, even if it's something where it's going to stretch you and cause you to have to research stuff. Of course, the disadvantage to metaclasses is that it's much less clean and much less clear if you use them improperly. In the beginning of the session, I quoted Tim Peters, who said that if you're not sure that you need a metaclass, you shouldn't use them. You should dismiss them out of hand. I respectfully dissent. If you're not sure, the right thing to do is to ask. The right thing to do is to do more research, to take the basis of this discussion of understanding the relationship between instances and classes, and the relationship between classes and metaclasses, which is the same relationship, and continue on to figure out how you can use that to make, to fit your particular use case. But don't dismiss it outright just because you don't yet know with certainty. The problem that you're trying to solve should always be what defines your solution, not your current skill set. That said, it's also good if you know what you're doing. There's another famous quote that says that debugging is twice as hard as writing code in the first place. And if you're writing your code as cleverly as possible, as interestingly as possible, if you're at your limit of niftiness for an esoteric way to do something, you are almost by definition not smart enough to fix it when it doesn't work. If metaclassing is the right solution to your problem, take the time to understand even more thoroughly than I could ever discuss here what it is you're doing. Ask those questions. And speaking of asking those questions, if anyone has any for me, now is the time.
So when you declare a class in a program, the interpreter is going through and you say class foo inherits from object, whatever. And then when you see the declaration, it immediately instantiates that as a class of object, or as an instance of object. And then you go through and you have your underscore metaclass equals whatever. Then does it go through and change the type of the object then? Or when does it actually get tagged as an instance of this metaclass rather than an instance of object?
So I'm going to repeat the question just in case. The question is basically a deep dive into the interpreter, and it's asking if you create a class, class cat, and then dunder metaclass equals, meta or whatever else, at what point does the interpreter go and say that this class has this other metaclass? The short answer to that question is I'm not completely sure. I am pretty sure that that's kind of a one-step deal, and that so metaclasses in Python 2 were added Pythons 1 and 2 were added a little bit as an afterthought. The history here is that there's these old style classes and these new style classes. New style classes are the ones that inherit from object and get this extra thing, and it was kind of shoehorned into the syntax. I'm pretty sure that the interpreter goes and looks immediately to see what the metaclass should be, either based on the subclass or based on an explicit declaration, and uses type if nothing is found. In Python 3, I'm a little bit more sure that it's a one-step deal.
If I can make more of a comment than a question, yes, if you have an under metaclass, it never looks at that base to get its metaclass. And just to clarify one other thing, when you say class foo of object isn't the metaclass. And I think the person asking the question was maybe a little confused about that, because what happens when you inherit object, which is an instance of type, it looks at its metaclass and propagates it that way. That's the same reason that if you do class, something inheriting model in Django, it uses its metaclass. Model itself isn't the metaclass.
So to repeat what Mike just said for the recording, basically one thing that I didn't cover in very much detail is that these things subclass down. So if you explicitly declare a metaclass for your class, then it's a sign. If you don't, I said earlier, and this was a little bit, it wasn't inaccurate, but it was certainly imprecise. If you don't do that, it just uses type. That's not really true. If you don't do that, first it checks any superclasses that you have to check to see what their metaclass is. So if you do, class user inherits models.model, the first thing it says is, did you declare metaclass on class user? Well, no, you didn't. Okay. It doesn't immediately then use type. It then checks models.model and says, okay, what is models.model's metaclass? And I actually think it doesn't have one either, and then it goes to like models.base model, and it does, and it uses model base. And so that goes back down. So the order is actually, it checks first your class, then the superclass chain, and which, of course, if you're using Python 3, goes to object. If you're using Python 2, hopefully goes to object because you're explicitly inheriting from object. And object actually has an explicit declaration of type as the metaclass. And that's how that is done.
Can you give some heuristics for when and when not to use metaclasses, how to make the decision?
So the question that was asked was, give a few more examples on when and when not to use metaclasses. When to use metaclasses. Metaclasses are great for being able to define subclasses more simply. They're able to say, okay, make this, if you're telling someone else, or if you're going to make a lot of them, and you want to say, make this subclass, define these, few things, and you'll get this behavior. But in fact, the behavior is much more complicated and involves some airlifting. Again, the Django models are a great example. You define your field classes, and then it airlifts them off somewhere and gives you, ints and bools and strings. Whenever you need to do stuff like that, where your class declaration doesn't look like the actual instance, the data the instances are going to have, that's probably a really good argument for metaclasses. Any kind of API creation. That's probably the number one reason I can think of when not to use metaclasses. Generally, this isn't going to be a hard and fast rule, but I would say generally, if you can do something with just base classes, probably that's the way to do it, unless the use of a metaclass greatly simplifies the amount of code that needs to be written and reduces the possibility for bugs. I would also mention that metaclasses are not supposed to be a part and parcel substitute for class factories. They solve different problems. Metaclasses still take defined arguments. You have a couple opportunities to play with them, but not very many. Class factories are much more open, but much less efficient.
Could you talk about some metaclass conflicts or metaclass errors, such as, say, with Django Tasty Pie, as long as we're talking about Django, when you declare a Tasty Pie resource, you declare class meta. If you try to use type to instantiate many different but similar resources, then you run into some problem, like declaring class meta gets sort of complicated. Could you talk more about metaclass conflicts and the sort of errors that you'll get working with metaclasses?
Not very well on stage. So the question was actually if I could do an illustration of some of the conflicts that you can get with using metaclasses, particularly if you try to use metaclasses that are incompatible or run into some inheritance things. The answer to that is not very well, and certainly not on the spot. I also have an issue of time. I think I'm out of it. So I am going to go ahead and dismiss this. If anyone has any more questions, feel free to bum rush the door over there, and I'll be over there so we can make room for the next speaker. Thank you all for coming.